Welcome back. These are the last notes for college algebra as far as what's relevant for the final. Um, so I want to make sure that we are going to still do stuff after college algebra, but these are the last notes that you need in order to be successful in your math classes next year. So quick thing that we kind of skipped over just because it wasn't on the final, and obviously we're not in the same situation as we were before. We were looking at domain of exponents. We know that, for example, we have a function like y equals a to the x. The domain is all reals, which means you could basically put any x value in and you're going to get some kind of a value, right? I mean, the domain is all the possible values of x, but really when we think about it is what doesn't work. And for exponents, you could put any x value and you're going to be fine. However, for logarithms, those are a little bit different. Remember, logarithms are the inverse of the exponents, and so for exponents, the domain was all reals, but the range is greater than 0. Well, for logarithms, it's the other way around. So if I have y equals log of x, that means that the domain is x has to be greater than 0. Now, this changes, of course, if this is like x minus 1 or x minus 2 or something like that, we have to adjust. So just know that the x values have to be positive. So the input here has to be a positive number. And if you think about y, when you raise a number to a negative number, you don't get 0, you don't get negatives, you get a fraction. If you raise it to 0, you get 1. So, there's nothing that you're going to be putting here that's going to make this into a negative number or anything less than 0. So that's just something to think about. So now when they ask you for a domain here, we're not going to officially take the time and find a domain. We're just going to solve. But be aware that some of our answers are not going to work, and we have to just do our job and check them. So going back to our, part of the things I miss about normalcy, about not having a regular class, is I like it when you guys read. So normally you guys would read this, and then we follow the steps. So if you have one log, so here, you divide both sides by the coefficient of the log and change to exponential form and solve. If we have two logs or multiple logs, simplify each term, use the power rule to eliminate coefficients, combine logs to change the exponential form and solve. Basically, with both of these, the goal is to change to exponential form, because even though some of you guys are starting to speak the language of logs and can understand like what the question is really asking, it's usually a lot easier to change to exponents. So let's take a look at a, for example. We want to isolate the logarithm, so we're going to divide both sides by 6 first, okay? Or you could raise it to the other side. Let's just divide by 6. So we have log base 4 of x is equal to 2. So I'm going to divide both sides by 6. And now, some of you guys, again, that speak the language of log can look at this and say, oh, well, what number do I raise? 4 raised to what power is x? That's what the question is saying. So you guys could figure that out pretty easily. But some of us who don't speak the language of logs, we're going to translate this to exponential form. Okay, so remember, this is our base. Base is base, so it's still base 4. Remember, logarithm is equal to the exponent, so this is going to be equal to 2. And the input is the solution over here, okay? So we call this the input, and that's going to always be what you're setting your exponential equation equal to. So now we have 4 squared is equal to x, which means that x is equal to 16. Now our domain here, this answer works, it's good, because our domain, because it's just log base 4 of x, is x is greater than 0. So our answer works out. Okay, let's try another one. So again, our domain, well, we would have to set this to greater than 0, and then we would solve, and this is a quadratic, and there's like little tests we have to do, but we will if there's a problem that we get, we will check the answers, and then we'll see if that works. But the domain for this is from negative infinity to 0 and from 6 to infinity. So if we get anything that's in between 0 and 6, it's not going to be good for us. All right, so let's solve. We have a single log, which means that we can just go ahead and translate it right away. So this is your base, 2 to the 4th power. Okay, this is my exponent, is equal to x squared minus 6x. And again, I told you guys like logarithms is one of my favorite things because it's like a little puzzle here. So hopefully everyone could see that this is an equal sign. Hopefully everyone could see that we have a quadratic equation. And so we have 16 is equal to x squared minus 6x. And we know that we have to set it equal to 0. So x squared minus 6x minus 16 is equal to 0. And of course we factor. We're going to get two numbers whose product is negative 16, whose sum is negative 6. So it's x minus 8 times x plus 2 is equal to 0. And our two solutions are x is equal to 8 and x is equal to negative 2. Now before you say like, well, you told us that it can be negative, I said that the domain can't be negative. I didn't say that necessarily x can't be negative. So we could substitute this in if you're worried about it. And we just plug it into here. So we're going to get negative 2 squared minus 6 times negative 2. So that's 4 plus 12, which is 16. So we're good. Yeah, so you can always check your answers if you're not sure. So both of these are correct. Now, going back up to our directions here, if we have multiple logs, simplify each term, use the power rule to eliminate coefficients, combine logs, change exponential form, and solve. So we have two logs here. We have log base 2 and we have log base 2. Thankfully, they're both the same. So now we're going to simplify this. So we have this 2 out here, so we know we're going to bring it to the top. And now we have log base 2 of 4 plus log base 2 of x minus 6 squared is equal to 4. And again, I consider myself pretty decent at math, but I can't look at this and say like, oh, I know this answer, right? I gotta do the steps. So I'm going to take my time and do the steps. I notice that there's a plus sign here, so we know then we're allowed to combine them if they have the same base. So now we can rewrite this as log base 2 of 4 times x minus 6 squared is equal to 4. And again, I do speak the language of logs, but I can't answer this question just by looking at this. I got to change it to exponential form. Now, we see that it's x minus 6, so our domain is going to be x is greater than 6. So let's go ahead and change it to exponential form, and we have 2 to the 4th power is equal to 4 times x minus 6 squared. And nobody in this class better ever say that this is x squared minus 36. We have to expand it. So 16 is equal to 4 times x squared minus 12x plus 36. And distribute and move the 16 over. I gotta write smaller, we're running out of space here. So we're gonna get 4x squared minus 48x plus 144 is equal to 16. Bring the 16 over. 4x squared minus 48x plus 128 is equal to 0. Factor out the 4. We get x squared minus 12x plus 32 is equal to 0. And then we factor. We get x minus 8 and x minus 4, which means our two answers are x is equal to 8 and x is equal to 4. So let's check. This one is in trouble because if I substitute 4 in, I'm going to get log base 2 of 4 minus 6, which is log base 2 of negative 2. This will never happen. There's nothing you could raise a number to that's going to give you a negative 2. So we call this extraneous. This is an extraneous solution. So our only real solution is x equal 8. All right. So again, we're not going to go into fine details of finding a domain, but you're going to have to check your answers. All right. So this is a little fun one. So we have minus sign. We have it to the 1/8 power. Okay. The domain. Well, we have two things here. Let's go ahead and just combine them first. So now division. So it's x squared plus x divided by, oh, that's right, in the old notes I made this into a plus sign because it was redonkulously hard. All right, we're gonna skip this one. I don't want you guys to get more confused here. So if you tried it, good for you. Just kind of do the setup for you. I was looking at my old notes here. And then this is 1 over 8 to the first power is equal to x squared plus x over x squared minus x. We could factor out an x here to make life a little bit easier. So 1/8 is equal to x times x plus 1 over x times x minus 1. Okay, these will, you divide them out, you get 1 here. So now 1 over 8 is equal to x plus 1 over x minus 1. We cross multiply here. 8x plus 8 is equal to x minus 1. Finish solving. We get 7x is equal to negative 9. Divide by 7. X is equal to negative 9/7. So now all we'd have to do is check our answer and substitute this negative 9/7 in to see if this works. Okay. Don't worry, I'm not going to ask you anything like that. All right. Okay. So this took a long time, and I don't like making these videos longer than 12 minutes. So we're going to stop for right now before we go on to the next kind of problems.